demonstration of our artistic robotic arm. This is our winter semester project for ECEN 361. What we have here is a robotic arm that was designed to draw whatever input that was given by this bamboo tablet. Now, the interesting part about this project was we had to create drivers in order for this tablet to work with our Raspberry Pi. As you can see, we are able to take those coordinates and the information provided by this Pi and then send them to the Arduino to be able to convert them into coordinates that the robotic arm can use. We have to use an interface called Pygame to collect these coordinates, which is able to take them and convert it to the Arduino.
In here we have the Raspberry Pi, which is getting the coordinates from the bamboo tablet, and then sending it to the Arduino, which is actually telling the arm where it should go. The protocol to send between the two, we had to use the serial connection to go from the Raspberry Pi to the Arduino to give certain coordinates on where we want it to be. In order to do that, we had to have a handshake value sent from the Raspberry Pi that said this is where the code is starting. And then we also used a function called parseInt to be able to send a string from the Raspberry Pi and convert it into a set of integers that the Arduino could then use to move the robotic arm. Another input that we used was this button, which changes colors of the markers. So as we push this button, it starts an interrupt on the Arduino, and it moves the rotation of the arm to select different colors if the user would like that.
As stated, the X and Y coordinates that were sent from the Raspberry Pi are converted using inverse kinematic equations that essentially become angles that allow the arm to find the correct position on the board.
To make the arm, we simply went onto Google and typed in robotic arm. There's a great website called Thingiverse. They have lots of examples of different types of arms that you can make. We chose this one. I believe it was 5 degrees of freedom initially, and we only use 4 of those degrees. This robot did not come with this custom-made marker holder. We had to make that. We used SolidWorks to create it, and then a 3D printer to print it out. And the whole process for making the arm took about 20 hours. With a student schedule, it probably could have been faster had we not had homework and schoolwork and work. But overall, our project works fairly well, as you can see. There are many things that we would like to change. One of them would be the wrist. We would no longer use it to control whether the pen is up and down. We would actually find a different means of raising the pen up. As well as the marker holder, it is a little bit big, and so it limits some of the movement when it comes close to the stand that is holding the robotic arm. And it's been a fun project, and if anyone would like to improve upon it, we would like to see what you can do. Thanks.